This is question number 11. I have to draw the figure to explain the question. We got the x and y axis. And we have a curve that is moving like this. So we got a point A, and this is the origin, or 0, 0. Now let me write the question down. The diagram shows the curve with equation y is equal to 9 times x raised to the power of negative 1 over 2, negative 4 times x raised to the power of negative 3 over 2. The curve crosses the x-axis at point A. Right, so this point is A. Find the coordinate. Find the x coordinate of A. Okay. Now let's do this part first. So given y is equal to 9 times of x raised to the power of negative 1 over 2, negative 4 times x raised to the power of negative 3 over 2. Now for x intersection, what do we get? We get y is equal to 0. So this means 9 times x raised to the power of negative 1 over 2, negative 4 times x raised to the power of negative 3 over 2 is equal to 0. Now what I wish to do is I would like to take a x out. Now negative 1 over 2, negative 1, this is going to be giving us negative 1, negative 2 over 2, and that's negative 3 over 2. Now why do I do this? I just want to take this x raised to the power of negative 1 over 2 out. So if I were to do that, that would give me 1 here followed by a negative 4 times, right? So I will have a x raised to the power of negative 1 there, because this, when it goes here, by the law of indices we will get negative 3 over 2, that will be equal to 0. Now 9 times x raised to the power of negative 1 over 2, we cannot equate it to 0. If we equate it to 0, this quantity becomes 0. Right, so that would mean we have 1 negative 4 times x raised to the power of negative 1 is equal to 0, which in turn would mean 1 is equal to 4 times x raised to the power of negative 1, which means 1 is equal to 4 over x raised to the power of positive 1, because it goes down. That means x is equal to 4. So therefore the coordinate A's coordinate is going to be 4, 0. So I got that value for A. Now we need to move to the next part. So I have to write the second part of the question. So what is the second part of the question is, this is part 2 or part B. Find the equation of the tangent to the curve at A. Right, so we need to get that value. Now for this, the equation of the tangent to the curve at A, now we are actually talking for the coordinate A of 4, 0. Right, now we have been given the curve to be as y is equal to 9 times of x raised to the power of negative 1 over 2, negative 4 times x raised to the power of negative 3 over 2. Now we will have to find the slope. So for that we need to calculate dy over dx. So we differentiate this, and that would give us 9 times of negative 1 over 2 times x raised to the power of negative 1 over 2 negative 1. That's the first part. Right, you differentiate x raised to the power of negative 1 over 2, followed by negative 4 times 9, that's going to be 36. So let me just place the 9 there. That is multiplied with the differentiation of this, that's going to be negative 3 over 2 times x raised to the power of negative 3 over 2 negative 1. So if we were to rewrite this, this is going to be negative 9 over 2 times x raised to the power of negative 3 over 2. 9 times 4 is 36, but there is a 2 there. So 2 divides 4, 2 times 2 times 9 is 18. There's a 3 there, so 18 and 3, there's a negative there, so this will become positive. X raised to the power of negative 3 over 2 negative 2, that's negative 5 over 2. Now this is dy over dx. We need to get it at a of 4 comma 0. So that in turn would mean negative 9 over 2 times, I have to place 4 there in place of x. So let me push the x down. So that's going to be 4. I am going to be rewriting it as 4 raised to the power of 1 over 2, and I will move the 3 out. That will be simple to solve. 18 into 3, 8 3s are 24, 2, 3 1s are 3, 4, 5, and I will rewrite this as 1 over 4 raised to the power of 1 over 2 raised to the power of 5. Right. So this is going to give me negative 9 over 2. 4 raised to the power of 1 over 2 is nothing but root of 4. Root of 4 will give me 2. That is raised to the power of 3. Positive 54. This is going to give me 2 raised to the power of 5. Now this is going to be negative 9 over 2 raised to the power of 3 is 8. 8 times 2 is 16. And this is 32. So I have a 54 and a 32. Now 2 divides here 1 and 16 times. 2 divides here 2 and 7. So that's going to be 27 over 16. So if I were to take the LCM, you have 18 over 16, and if I were to use 2 divides 8 times, 2 divides 9 times. So this is going to be 9 over 8. So therefore the equation of the tangent at a of 4 comma 0. So this is x1 y1. So it's going to be y negative y1 is equal to m times x negative x1. So y negative y1 is 0. Now m is 9 over 8, x negative 4. So therefore y is equal to 9 over 8 times x. You can stop it here, or you can just distribute that. Distribute 9 over 8 throughout. So that would stop it here, and means I'm actually meaning this part, right? So if you want to elaborate this, just distribute 9 over 8 throughout. So that would give you negative 9. 4 divides 8 2 times, so you have a 2 there, and that is the equation of the tangent at the point 4 comma 0. Right, so we have to move on. Let's go to part C. In part C we are asked to find the x coordinate of the maximum point. Okay, x coordinate of the maximum point of the curve. Now for this, what we have to do is to get the maximum point, the x-coordinate of the maximum point of the curve. The solution is we need to set dy over dx to be equal to 0. Now previously we know that dy over dx is equal to, so we calculated dy over dx, right? I'm going to utilize this. So it's going to be 9 times negative 1 over 2 times x raised to the power of negative 3 over 2, followed by negative 4 times 9 times negative 3 over 2 times x raised to the power of negative 5 over 2. This is what we have got. Okay, now this is equal to, now we are setting dy over dx is equal to 0, right? So let me write that down. Set dy over dx is equal to 0. So that in turn means negative 9 over 2 times x raised to the power of negative 3 over 2. I already told you that 2 can divide 4 2 times, so that's 18, and 54 positive sign, negative is positive, so x raised to the power of negative 5 over 2. This is equal to 0. Now what I wish to do is I will take 9 out, and is it possible for me to take an x out? So if I take an x out, let me write it like this. I can take 9 out, x out, x raised to the power of negative 3 over 2, and that in turn would give me a negative 1 there with a 2, right? And when it comes to 54, I will have a 6 there, and if I were to place x raised to the power of negative 1, that would give me negative 5 over 2 is equal to 0, right? So this would mean negative 1 over 2 positive 6 x raised to the power of negative 1 is equal to 0. This means negative 1 over 2 is equal to negative 6 times x raised to the power of negative 1, which in turn would mean negative 1 over 2 is equal to negative 6 over x. So this will become positive, so you cross multiply. This means x is equal to 12. So that's a solution for this question. We are expected to find the area bounded by the curve from x between the x-axis and the line x-axis and x is equal to 9. So we are expected to integrate. The required area is going to be x is equal to 4 to 9 times of x raised to the power of negative 1 over 2, negative 4 times x raised to the power of negative 3 over 2 times dx. We have to integrate this. So this is rewritten as 4 to 9. I'm going to distribute 9, so it's going to be 9 times x raised to the power of negative 1 over 2 times dx. Negative 9 times 4 is 36, integral 4 to 9 x raised to the power of negative 3 over 2 times dx. You integrate this, you get 9 times of x raised to the power of negative 1 over 2 positive 1 divided by 1 over 2 positive 1, 4 to 9, negative 36 of x raised to the power of negative 3 over 2 positive 1 divided by 3 over 2 positive 1, limits of 4 to 9. This would give you 9 times of negative 1 over 2 positive 1, that's going to be 1 over 2, 4 to 9, negative 36. This is going to be negative 1 over 2 divided by negative 1 over 2, 4 to 9. You flip this, you get 18, and you have x raised to the power of 1 over 2. You substitute the upper limit, you get root 9. Lower limit is substituted, that's going to be root of 4. Now 36 you flip, negative positive is there. 36 you flip, or I would say 1 over 2 you flip, you get 36 into 2. That's going to be 72 there. And this is a negative exponent, so it's going to be 1 over root 9 negative 1 over root 4. Now this is going to be 80 now. Root 9 is 3, root 4 is 2, 72 times, this is 1 over 3 negative 1 over 4. Now you take the LCM as 12, you get 4 negative 3, and you have a 72 there. 3 negative 2 is 1, you have an 18 there. Now 4 negative 3, that's going to be 1. Now 6 divides here 2 times, and 6 divides here 12 times. And in fact, I could have utilized 12 itself, and 2 divides here 6 times. Okay, fair enough. So you have 18 positive of 6